Everyone. Welcome to the last and the ninth episode of Smart City Waters webinar. Today is going to be the last episode, the last session that we have for the webinars. So the summer is over, and then we're planning to have more um, sessions going on, most probably in either fall or in winter. We're going to have a session with WEAO. So it's going to be a joint session that we have. But today is going to be the last one that we will cover, and we will keep you guys posted. And if you guys want to review the last sessions that we had, we talked about dual drainage modeling. We talked about it theoretically, and also we worked with VO Swim. We talked about land use development or land use change and land development using Visual ATMO and VO Swim. We also talked about the impact of climate change, so feel free to check out our YouTube channel. So if you just on YouTube, if you search for Smart City Water Incorporation, you can find us, and all the sessions are there. This session is already being recorded and is going to be published as well. Today, we are going to talk about the new CLI ECA legislation and what exactly is the manhole INI analysis and what exactly we're looking for. So I'm going to talk about it. Again, I'm Jason Mahmoudi. I've been talking about different things with you guys over the last 5-6 sessions of the webinars. Today, we are going to talk about the ECA legislation. ECA stands for Environmental Compliance Approval. This is the new one. This is a very new legislation that came out. I believe the last session of the webinar from MECP was in June 22nd, if I'm not mistaken, that they were talking about. So this is official now. This is out. So if you guys want the legislation, the final draft or the published one, feel free to either Google it or even you can ask me, you can email me and I can send it to you if you're interested to go through it. However, I just took a snapshot and a screenshot of one part of it that I wanted to talk about, which is going to be related to our topic today, and that is the design criteria for sanitary sewers. And then, so in that section, the second chapter, so part 2.10.7 and 0.8, there are two parts that are talking about the manholes. So the maintenance holes for the sanitary sewer, there are two parts that just added to the new ECA legislation, and it is very important for either the consulting firms or the municipalities that are dealing with the sanitary sewers. So I'm just gonna read it and then explain what exactly it is asking us to do. So the maintenance holes or the manholes shall be located away from any route or ponding area. Grading around manholes shall be benched to direct water away from the maintenance hole. So what it is saying is so we have the sanitary sewers, and then the sanitary sewer have the manholes for maintenance purposes. So the new design criteria for the sanitary sewer are asking us to locate these sanitary manholes away from the routing or ponding area. So technically, any overland flow, we should do all our best to locate the manholes for the sanitary manholes. We should locate them away from the overland flow. However, it is almost impossible for a lot of occasions. So that's why in the next part 2.10.8, it says, in case where the sanitary manholes cannot be located away from an overland flow route for a 25-year storm event or cannot be benched, an analysis must be completed to verify, number one, if the overland flow will submerge the manhole, the maintenance holes, or number two, it's not or, it's and. Number two, where more than one consecutive manhole, sanitary manhole, requires sealing due to exposure to overland flow, appropriate ventilation shall be provided. So technically, it is asking us to do a manhole inflow and infiltration analysis. Well, technically, we can do inflow analysis to see if first of all, we should do all our best to locate the manholes of the sanitary sewers away from overland flow. If it is not possible, we should do an manhole INI analysis. INI stands for inflow and infiltration. We should do a manhole INI analysis to see the overland flow, a 25-year storm event, if it is going to submerge the manhole. And if more than 3 manholes, consecutive manholes, are going to be submerged, we need to do the ventilation. So in order to better understand what exactly we're talking about, I provided this one. So this is what exactly we have. This is the sanitary sewer, and this is the storm sewer. The storm sewer, we're going to have catch basins, which are going to collect the storm water and then dump it to the storm sewer, and then we're going to get rid of it out of the urban area. However, we have our residential area, and the residential area are going to connect to the sanitary sewer via the lateral that they have. So many times we're having let's say some trees, some plants, and then the trees' roots are going to cause some fractures or some damage to the lateral of our sanitary sewer or sanitary sewer system. And then because if we have the sanitary pipe and if there is a fracture on that pipe, because we're having flow inside of the sanitary sewer from our residential area, and if there is a pipe, so the pipe, because we have flow down there, we have flow in the pipe, we're actually generating a negative pressure. And the negative pressure in real and in physical world, it means that we're going to have suction from inside of the pipe. From inside, we're going to have suction. So if we have any, let's say, infiltration, if we are having a heavy rainfall, the rainfall is infiltrating through the grass area, through our backyard, our front yards. When the water is going down there, because we're having flow inside of the sanitary pipe, we're having suction. So the storm water is going to be sucked into the sanitary system, and we're technically mixing the sanitary water with the clean water, and we're having excessive amount of water entering the sanitary sewer. So that is called the infiltration sources. However, the inflow sources, we're having the sanitary manholes, which we can see here. Most of the times in Ontario, we're having the orifice two-pick holes. So there are 2 holes in the sanitary manhole lid or manhole cover. And when we're having overland flow, the overland flow will enter the sanitary sewer via these 2 holes. Also, because it's not sealed, we are having some fractures here. We're actually allowing the storm water entering the sanitary system. So VOSwim is the first software, is the only software right now that can actually do the manhole INI analysis right now. So what you can do is you can model the manhole lid, and then at the end, after running the model, we can do a manhole INI analysis to see which manholes, the sanitary manholes, are submerged. This is exactly what part 2.10.7 and 8 of the new ECA legislation requires us to do. So I'm going to open the software, and then all right. I'm going to open the software. to get a hands on the manhole INI analysis. So in order to do the manhole INI analysis, we need to have a dual drainage modeling already set up. So that's why I'm going to use the dual drainage model that we did in the last two sessions, session 7 and 8. So if you guys missed that one, feel free to go through our YouTube channel, check out the videos with it, the entire dual drainage modeling from scratch. And we can check out the YouTube channel for the videos. And if you want the actual model, feel free to ask me. I'm more than happy to provide it to you guys. So again, this is the VO Swim. This is the interface of VO Swim. If you guys are interested to work with VO Swim, again, feel free to ask me. I can create a free trial for you guys and check it out. And if you're interested, so what I'm going to do is I'm going to open the project. I'm going to open the dual drainage modeling project that I had. Oh, I accidentally just closed it. Excuse me. So this is the dual drainage modeling that we had. I'm gonna clean it a bit. There we go. So we have already our outlets connect what we created our overland system. We connect them to our drainage system, which is sanitary and storm sewers. So the very first thing that I need to do is I need to make sure that my outlet links are all taking inflow rating curves into consideration. So what I need to do is I need to go through the parameter table, select all of my outlets by holding the Control A. All of the outlets that I have on the properties tab, we can see that under the parameter, there is inflow rating curve. So I want to make sure that I check this out because I want to make sure that my outlets are actually taking inflow rating curves into consideration. And then at the end, like later on, through this session of the webinar, I'm going to assign the rating curve to these outlets that I have. So this is the first thing that I need to do. And then I need to select the manhole inflow sources as well. In order to do that, I need to go through the junctions. You can select them on the real map. All of these red dots, we talked about it. These are the sanitary manholes. And an easier way to do so is you can go through the parameter table under the junctions. You can, by clicking on system type or any of these headers, you can sort them based on that. So I'm gonna sort it based on the sanitary. Click on the first one and then find the last one. I'm gonna hold the shift button on my keyboard and select the last one. So now I'm selecting all the sanitary manholes. By clicking all the sanitary manholes, the very first thing that I need to do is I need to make sure that there are manhole inflow. So I need to make sure to check that manhole inflow button. And then when I click on manhole button, I will see that down here, this one just popped up. Because when we had the manhole inflow unchecked, we didn't have any manhole inflow. But when we check it, the manhole info will pop up here. What I need to do is I need to make sure that both of these two have values for all the sanitary manholes. The rating curve source, by clicking on these three dots, mine is orifice 2-peak manholes. So I will just click on orifice 2-peak holes, click OK. So what I need to do is also I need to assign the channel depth before the inflow. So we have some sort of a depth of a flow before we reach to the manhole. So you can, all these values when we're modeling manhole analysis are provided by either we can go and get the data, like calculate the data, or most of the times these data are provided by the clients that we have. So you can either manually input the data, you can just select each of these and then go here and then let's say 1.2 or whatnot. You can just manually input, or you can create a CSV file, especially if you're having a big project, if you're having a lot of manholes, it may not make sense to do so. In order to save a lot of time, you can create a CSV file, and the CSV file needs to be 2 columns. The first column is the name of the Nash height. So let's say, for instance, NM-N13-0254, and all the Nash height names. And then on the second column, all you need to do is just put the numbers for associated with each of the Nash heights that you have. I'm going to use the latter. So the micro drainage ribbon, and I'm going to go to assign manhole inflow rating curve. Oh, I'm sorry, the assign manhole inflow depth. By clicking on that one, it will ask you for the path of the CSV file that we have. So my CSV file is here. So the manhole channel depth, as I said, 2 columns. The first column, the Nash height name. The second column, the depth of the channel before the inflow. So I will click OK. 8 values are assigned. Now, if we select each of these, the sanitary manholes, you can see that the rating curve, it says yes, and also the channel depth before the inflow has been updated. There are different numbers because each manhole has different channel depth before reaching the manhole. Excuse me. So the next thing that we need to do is we need to assign manhole inflow rating curve. If you remember, we were talking about the outlets. We said we made sure that the inflow rating curves are checked. Now we need to assign the curve, the actual rating curve, the inflow rating curve for each manhole. So in order to do so, we're going to micro drainage ribbon, assign manhole inflow rating curve. Ours, as we talk, is the orifice 2 pick holes. And if you want to see the rating curves value, or if you want to edit them, you can go on the collection on these 3 dots. This is the actual rating curve for the manhole. So the manhole inflow rating curve that we are selecting is this one. If you want to change the value, you can do it manually, but this is typically the default for the orifice 2 pick holes that we normally have. So this is technically the standard. So if you have a project that it was not a standard or you needed to change it, you can just easily change it here. And by clicking on generate, we are going to generate the rating curves for the outlet links that are used for manhole inflow modeling. So we checked the inflow rating curve for all the outlets, and by generating we're generating the actual inflow rating curve for all the outlets and all the manholes. So right now, if I go through the outlet, if I select any outlet, I can see that the tabular curve is updated by clicking on these 3 dots. And here I can see that the rate is actually updated. Now I have a head and I have an outflow, and it has been updated by the assign manhole, but the previous step that we just did. So our model is almost complete right now. We assigned the inflow rating curve to the outlets. We made sure that the outlet is taking the inflow depth, the inflow rating curve into consideration. We modeled the manhole covers for the sanitary manholes. And now all we need to do is you just need to run the model. If we want to follow the same thing that the ECA legislation talked about, we can add the 25-year precipitation, the 25-year 6-hour based on AEC. So we can add this to the model. And then we can run the model. I'm gonna run the model based on this. I'm just gonna make sure that the setting is the end analysis in 12 hours. And this is 1. Now we'll run the model. The model is complete. So we can check the result now. For sure, we can check the result for any of these that we talked about the last session that we had. That was for dual drainage modeling. However, what I'm looking for right now is the manhole inflow analysis. So we came up with lots of toolbox for flood mapping, for surcharge and flooding analysis, and also for manhole inflow analysis. We technically can't do the infiltration analysis because for infiltration analysis, we technically need to do flow monitoring. There are so many different ways to do flow monitoring. Also, Smart City Water does provide flow monitoring, and data current is the module to do so. But because we have no idea what exactly is going on down there in the laterals or in the sanitary pipes, and we need some machines or we need some system to go through the sanitary pipes to check out if there is any infiltration. So technically what we're doing is the manhole inflow analysis, is what we're seeing through the manhole lids. So by clicking on manhole inflow analysis, it is very straightforward. It only asks you which run you want to use, and if you want to update your map with the submerged sanitary manhole locations. Yes, I do want to update my map, and then this is what we got at what we get at the end. So there we go. I'm gonna update my legend. So map legend here. I want to see the junctions because these new junctions, I want to see what red junction means, what black junction means. And then by clicking OK, I brought them up here. I'm going to increase the legend. So the red ones are the submerged manholes. These two sanitary manholes are submerged, and these black ones are not submerged. So this is exactly what the ECA legislation is asking for. So if we happen to have 3 submerged manholes, consecutive manholes, sanitary manholes that are submerged based on a 25-year precipitation, then we need to do, or we need to provide ventilation. So also, if you wanted to check out the result by the summary table, you can do it as well. So some result summary table, you can just select on the junctions, and then you can sort the junctions based on by clicking on submerged. These two are submerged. These two are exactly the red ones that we were seeing. So if you wanted to not update your map and just saw the previous map that we had, which had the sanitary system, sewer system, overland flow, if you wanted to just keep that map, when we clicked on manhole inflow analysis, you could easily just click on no to keep the previous map and check out the result on the result summary table by clicking on junction, sorted by submerged, and if you click on it, it's going to show you which manholes are submerged. So that was as easy as we saw. Again, in Smart City Water, we try to work on both Visual Alchemo and VO Swim to save time, because we are a bunch of water resource engineers. We've done modeling before, and we have PhDs in the team to give us the correct and solid theoretical and methodology to apply in our modeling tools and softwares. So I'm going to save this project as the last project that we had in Smart City Water. So if you guys are interested in the model, feel free to just email me. If you have any question, feel free to ask. I will answer them based on my knowledge if I could. So feel free to shoot me an email if you wanted to have the actual PDF of the new ECA legislation. If you guys had any question after this meeting, feel free to ask me. Just email me and I will be more than happy to answer to you guys. And yeah, so that was the last session of our webinars, at least for summer, and we will have it down the road as well. I don't think if there is any question. So thank you so very much for staying with us. That was a very quick last session of the webinar. Make sure that you have us followed on YouTube or Twitter or LinkedIn page. We're going to keep you guys posted. We're going to have lots of content for you guys down the road. And thank you so very much for staying with Smart City Water over the last 3 months. And until the next session that we see each other, have fun, make happy, and be happy. Cheers.